Alright, in this video we're going to keep on learning that new method that we've learned for changing units. And here we're going to work with area units and volume units. So basically squared units and cubic units, right? Cubic squared meters and cubic meters. That's what we're going to be working with today. Okay, so the idea is very simple. We're going to be doing the same thing as we did with all the other units, only that when moving from unit to unit, we're going to count each step double in case of the area and triple in the case of the volume. Why is this? Well, basically, because if we have a surface and we have one side and one side, like base and height, right? And for example, height is 1 meter and base is 1 meter. And we want to change the units of this square. We would be getting, for example, if we change it to decimeters, something like 10 decimeters times 10 decimeters, right? If we make the unit conversion. And so, in calculating the surface, as you probably already know, you calculate the surface of a square by multiplying its sides. So 1 times 1 is 1 meter squared. And if we calculate the surface of this square, which is the same size, only that we've written the sides in decimeters instead of meters, here we will get 10 times 10, which is 100 meters squared. Decimeters squared, sorry. So the conclusion from this is that if we make a change, if we change one unit in length units, one change in length units is equivalent to 2 in area or 3 in the case of volume. Why it's 3 in the case of volume? Because volume has base, height, and also profound, right? I know it's not called profound, but I don't really know the name. It has 3 dimensions, right? So 3 changes I have to make. For each change in length, I make 3 in the volume. It has 3 dimensions. So that's the basic idea behind the thing that we're going to work today. We will see this through some examples, but the basic idea is just count the number of steps and double it in the case of area, count the number of steps, and triple it in the case of volume. All right, so let's do some examples of this. I'm going to go with 25,000 hectometers squared, and I'm going to try to change this into kilometers squared. Okay, so first step is always writing down the number in scientific notation, which would be 2.5 times 10 to the power of 4 hectometers squared. And now I'll have to write down the equivalence. What's the equivalence between hectometers and kilometers? Well, since kilometers is beside hectometers, I only have to make one step to the left. But, so if it's to the left, it's going to be negative. And if it's one step, x would be, in this case, would usually be 1. But in this case, because it's a squared unit, then the exponent is going to be minus 2, because each step is going to be double. Instead of 1, we will have double 1, which is 2. Did we got this? So we will have 2.5 times 10 to the power of 4. And when we write down the equivalence, we're going to write down 10 to the power of minus 2 kilometers squared. Okay, so one step doubling the number of steps in the exponent. And finally, we will make the multiplication, and we will get 10 to the power of 2, because 4 plus minus 2 is 2. And we have the number in scientific notation in the desired unit. Okay, so let's see what we will do if we had a volume change of units. If we have a volume change of units, for example, okay. I have a problem because I can't see the pointer. It's gonna be difficult for me to write without the pointer, without seeing the pointer. I hope I can do it. If I have something like 350 meters cubic and I want to change this into hectometers cubic, it's very difficult for me to write without the pointer. I'm going to try to restart the application 1 second. All right, I think we got it. Okay, so first step would be writing the number in scientific notation, which would be 3.5 times 10 to the power of 2 meters cubic. And step number 2 would be writing the equivalence. But what is the equivalence between the meters cubic and the cubic hectometers? Well, we have two steps because we have to move first to the decameters and then to the hectometers, right? So two steps. But since it's a cubic unit, then it's going to be triple the number of steps. So 2 steps would be turning into 6. And since it's to the left, it's going to be minus 6. So when we write down the equivalence, we're going to write down 10 to the power of minus 6, because 6 is triple 2, which are the number of steps we're taking between these two units. And in that way, we will be changing between cubic meters and cubic hectometers. And in the final step, we will just multiply the base 10 powers, and we will get 3.5 times 10 to the power of minus 4 in this case, because 2 plus minus 6 is minus 4. Okay. I'll have to add that when changing between volume units, it's not the same changing between units of the same multiple and submultiple, or trying to change between different capacity units. I'll try to explain myself. We've seen how to change, for example, from liters to deciliters, and we've learned how to change just right now from cubic meters to, for example, cubic kilometers. But we didn't learn how to change between cubic meters and liters, for example. So between a cubic unit and a different unit. How can we do this? How can we make this change? Well, we're going to try to assess that as well in this video. First of all, we have to learn something about the equivalence between these units. And those equivalences could be summarized as 3. 1 cubic meter is the same capacity, the same volume, as 1 kiloliter, or 1,000 liters. 1 decimeter, 1 cubic decimeter, is the same as 1 liter. So, for example, a bottle of water, which is basically similarly sized as 1 liter, would have a capacity of 1 cubic decimeter. And finally, 1 cubic centimeter is the same as 1 milliliter. So knowing these conversions, knowing these equivalences, we can apply our method to change between different units, such as cubic units and liter units. Let's see an example. We can have 27,527,500,000 decimeters cubic, and maybe I want to change this into kiloliters. All right, so what should I do? First, I write down the number in scientific notation, 2.75 times 10 to the power of 8. This is the same as always. Now, second step, and this is the fundamental thing, I have to make an equivalence. I have to look at the equivalences that I have here. I got the cubic meter, I got the cubic decimeter, and I got the cubic centimeter. Since a cubic decimeter is the same as a liter, the equivalence between the cubic decimeter and the liter is just they're equal. I don't have to write down any equivalence, they're just equal. So I can write down the same number, but in liters. And finally, I will have a second step, number 2, which would be converting from liters into kiloliters, as we already know how to do. We would do 2.75 times 10 to the power of 8, and we will add the equivalence between the liter and the kiloliter, which is 10 to the power of minus 3, because we're moving to the left. We will make the multiplication, and we will get 2.75 times 10 to the power of 5 kiloliters. All right, so this is extremely important to learn by heart to make this kind of changes, or this kind of unit changes. And it's basically the same that we've learned, only that we have to make two steps, number 2, right? So 2.1 and 2.2. In the first of the two steps, we're going to make a conversion between the cubic unit and the liter, and then we're going to change between liter units, liter multiples and submultiples. All right, so let's see if we got this by doing another example, and we finish the video with this. Let's write down, for example, let's see, a different unit from this, right? 2, I'm always using the 2, I'm going to change the number. 8.8. Okay, again, I lost my pointer, 1 second. All right, 8.8 times 10 to the power of 2 cubic millimeters. Cubic millimeters. And I want to see this in centiliters, for example. So the first step would be writing down the number in scientific notation, but we already have the number in scientific notation, so this step is just pointless. It's the same thing. The second step would be converting the millimeters cubic to a liter unit. But if we see the equivalences we've learned, we see there is no equivalence between cubic millimeters, or I don't know any equivalence between cubic millimeters and liter unit. So what do I have to do in this case? Well, I have to change it into one of the units that I know the equivalence of. So in this case, I will have to change it to cubic centimeters, for example. If I change it to cubic centimeters, the equivalence is 10 to the power of minus 3, because it's only one step to the left. And I will move on to 8.8 times 10 to the power of minus 1 cubic centimeters. But this result is not in centiliters yet. I have to keep doing this conversion. How? Well, I would move now onto another step number 2, onto another equivalence. So this, because it's in cubic centimeters, it is the same as a milliliter. So I could write it as 8.8 times 10 to the power of minus 1 milliliters. But this is still not yet a centiliter. So I will have to add the conversion between the milliliter and the centiliter. And as you already know, the centiliter is one step to the left. So the conversion would be 10 to the power of minus 1 milliliters. And finally, I would write down the answer here, because I have no space more left. Finally, I would make the last multiplication and get 8.8 times 10 to the power of minus 2 centiliters in this case. I wrote this down incorrectly. This is centiliters. Okay, so we've seen how to change between area units, how to change between volume units, and how to change between squared and cubic units. As you've probably seen, this example is a bit more difficult than the other one, but it's just because we have no direct conversion. If we have no direct conversion, we have to make many conversions, many intermediate conversions in order to get to the final result. If we get an exercise which is already in one of the equivalences that we know, then it's going to be much faster. But this is not always going to be the case. It's not very difficult or more difficult, but it's just longer. So it's just how it is. I hope you liked the video. I hope it was clear. Hope you solved your doubts. And see you on the next one. Bye.